Good evening, one and all present here. I am Dr. T. Lakshmi Boy, Assistant Professor, Department of Computer Science and Engineering, and co-coordinator of this ATAL FDP. Before moving to our session, to ensure smooth and effective participation in the ATAL FDP, I request to follow the instructions. All online participants are welcome to the FTP, Smart Energy Systems for Climate Resilient and Sustainable Development, which is to be held from 22nd to 27th September 2025. I request all the participants must log in on time for all sessions. Late joining or early leaving may affect your certification eligibility. And then full attendance in all session is mandatory to receive the certificate. And participants are expected to actively engage by asking questions, sharing your views, and responding during discussions. And ensure a stable internet connection, functioning webcam and microphone. Use the laptop or desktop preferred instead of mobile phone for better learning experience. Keep your full name as per your registration while joining the online platform. Keep your microphone muted unless you are invited to speak. Use the chat box responsibly for academic or technical queries only. Please submit your feedback forms within the given deadlines. Certificate will be issued by ACT ATAL only if the participant maintains at least 80% attendance and scores minimum 70% marks in the online assessment test at the end of the FTP. And you should submit the feedback in the ATAL portal at the end of certification. Now, let us learn together and enjoy the wonderful session ahead. Now, our session resource person is with us. It gives me great pleasure to introduce Dr. V.S.K.V. Harish, Assistant Professor in the Department of Electrical Engineering at Netaji Subhash University of Technology, NSUT, New Delhi. Dr. Harish is an accomplished academician and researcher with a distinguished career. He completed his ME in Power Engineering with a gold medal from Jadavapur University in 2012 and obtained his PhD from IIT Roorkee in 2017, both with prestigious MHRD fellowships. He further pursued a postdoctoral fellowship at Terry School of Advanced Studies, New Delhi, working on a Netherlands government sponsored project on smart grids for rural India. His research excellence have been recognized globally. He was twice nominated for the Young Energy Researcher Award at the World Sustainable Energy Days in Austria and has received Best Paper Awards at Springer and IEEE international conferences. His contributions have also been supported by international and national travel grants from DST and SCRS. Dr. Harish has an impressive research portfolio with numerous publications in reputed journals, international conferences, and book chapters with the CRC Press and Springer. He is also a author of a book of renewable energy driven built environment. His Google Scholar profile reflects over 1,200 citations with an H index of 11 and I-10 index of 13. He is a proud member of leading professional societies, including IEEE, ASHRAE, CIBSE, and SCRS. His key areas of expertise and interest include built environment, power system analysis, and modeling and simulation. We are privileged to have Dr. Harish with us today, and I warmly welcome him to share his knowledge and expertise with us. Now, the session is yours, sir. Please welcome.
Thank you very much, ma'am. Am I audible?
Yes, sir. Yes, sir.
Sharing my screen now.
It's not visible, sir.
Okay. Sharing. Just a second.
Dear participants, please mute your.
Is my screen visible now?
Yes,
Now
yes,
it
sir.
is
It is
visible.
visible.
Yeah.
Yes, sir.
A very good evening and namaste all of you. Uh, Thank you very much, Professor Lakshmi ma'am, for the introduction. A very good evening, all of you. It is a pleasure to be here with all of you today. The theme of the talk is sustainable energy management. While we often think of the energy transition mainly in terms of generation, of course, heavily supported by the media as well, that we have installed so many number of solar PV panels and so much of wind energy power plants, so on and so forth. But that is one side of the story, with a new infrastructure is being developed in terms of renewable energy systems and in terms of storages. But what truly defines a resilient or a climate ready system is how we, the power grid operator, renewable energy system provider, and the end user, is managing that energy. How we are forecasting it, how we are optimizing it, how we are using it, how we are distributing it, and whether or not we are aligning it with our societal energy needs. So over the next 1 hour or so, I'll take you through the fundamentals of sustainable energy management, uh, primary key differences from the traditional approaches, and also majorly looking into what are our country's dream towards a sustainable energy future. Then we'll delve into my research that I have been focusing since last decade, as ma'am pointed out in my introduction, majorly during the building energy systems or the buildings to grid integration. But to understand it, it is necessary that we understand some main differences, because these are very loosely used terms, that is net zero energy building, energy efficient building, green building, and smart building. Smart grid, virtual power plant, microgrid. These are 7 distinct different terminology or technicalities. Then we'll look into how we develop a buildings to grid in integration framework, which is again a subset of next generation technologies. Another thing that I really want to put forth here is, as the title in the brochure suggested about the next generation technologies, it is important that we understand that what we have been fed by newspapers, articles, media, print and visual, is that whenever we talk about next generation, the one thing that really comes to our mind is communication, 5G, 6G. But when we talk about a renewable energy system or a electrical engineer, a next generation technology means a next generation solar PV, a next generation wind, a next generation demand response, a next generation control strategy, a next generation robustness. In a very similar fashion, I'll put forth what are the next generation technologies related to the sustainable energy management. There's one sincere request I have to all of you, to all the honorable participants, is that if you have any queries or any point that you want to raise during the course of the presentation, I very sincerely request you to interrupt me then and there. And if the coordinators allow, you can raise the hand or you can post it in the chat box, and I'll be happy to address that the issue or any point that you want to raise. So coming
Yes,
back,
sir. They can raise hands or post it in the chat box. Then we can address the queries one by one, sir, at the end.
okay, ma'am, fair enough.
Yes,
Okay.
sir. Thank you, sir. Thank you.
So let's begin this 1 hour journey by first understanding why management. Why do we require sustainable energy management, and why not only just generation? And why does it really matter in achieving a sustainable and climate resilient energy system? See, when we talk about sustainable energy, the term is not a new term. It is very familiar to all of us, even for a BTech student up till a postdoctoral researcher and a practicing academician or a practitioner or a understand is
Mà thúng tay cái gì gì được kìa.
you must have
Được cái gì?
term. But its exact definition or meaning so far has been very weak. So I thought that because this is again first technical lecture of this fantastic ATAL FDP, I thought that let us start with an universally, may not be universally, but one of the accepted definition or an adopted definition of sustainable energy. See, the definition of sustainable energy has been inspired by the definition of the sustainable development, which was formulated more than 3 to 4 decades ago in the UN's report of World Commission on Environment and Development. In that report, they talked about managing sustainable energy. It said that it is the practice of optimizing not only the generation, but the distribution and the usage of energy, the consumption of energy as well, to meet the current needs, right? Because 30 years ago, the needs were different. In 13 years, we have increased population. At the same time, it is not only the population, but also the standard of living. Our standard of living has also improved. That means the energy usage is improving, which is a good thing. One thing that I really want to put forth here in front of all of you, August audience, is usually it is being seen that, okay, energy efficiency or conservation means that you don't use energy. But that is not the case. Whenever you use energy, you have a good primary energy, secondary and tertiary energy consumption, and the total final energy consumption. You have a very good per capita energy consumption, which improves your human development index, which leads to an improvement of a nation, of a state, of a system, right? The thing is that you would be using that energy in a very efficient way, the first thing. And the second thing is you would be conserving that energy. Two things, energy efficiency and energy conservation are very clearly different things. I'll give you an example here. I don't know if I'm able to switch on my photo. Achha, okay, it's it. Or not, but I'll give you a example. Like, for example, if you would be sitting right now listening to this webinar or the technical talk, we may be using some sort of light for our illumination levels, fan, air conditioners for our air conditioning system, and also for humidity and CO2 conditioning. If I am changing the light from CFL to LED, from LED to super LED, from super LED to some other energy efficient technology, this process is energy efficiency. Changing a technology to meet the same user needs, to meet the same energy needs, is energy efficiency. I'll repeat again. If you are not changing your energy need, that can be an electrical energy need, that can be a mechanical power need, that can be a thermal energy need. If you are not changing its magnitude, but only changing the technology in such a way that the input energy is less, it is called as energy efficiency. Now let us talk about energy conservation. Energy conservation means you are not changing any technology. You are not changing your fan. You are not going for BLDC. You are not changing your light, but you are changing your behavior. You are changing your pattern of using that particular energy is called as energy conservation. Again, I repeat, energy conservation means you are changing your energy needs. The kilowatt hour, the horsepower, you are changing that need. In energy efficiency, you don't change that. Second, so I hope all of us are clear now. Second thing, when we talk about sustainable energy management, is the renewable energy usage. One thing is renewable energy system and renewable energy resources are two different things. When we talk about energy storage, we usually very loosely integrate it with renewable energy sources. But whenever we talk about renewable energy system, it is a system where there is a source, there is a load or a demand, and you may or may not have a energy storage. Now you will ask me, sir, then what is the difference between renewable energy system and microgrid? I hope we all know this. Majorly, again, we are dependent upon China, but we are increasingly working towards Make in India, Made in India concept. But most of us are aware of laltens, the lights, LED lights or LED lanterns, where you have a lighting load, which is a LED, and the back of LED, you have a small battery, which can be lithium ion. And in top of that LED lamp, you may have a small, very small solar panel. This is a renewable energy system. This is not a microgrid. Again, I repeat, this is not a microgrid. Second thing, microgrid is nothing but, again, one thing again I want to put forth in front of the august audience is that whatever definitions that I will be giving, because this is the first lecture, whatever definitions I will be giving in the course of this lecture will be coming from some reliable source, not Google, Wikipedia, or ChatGPT or Gemini. I encourage all of you to go through the Government of India's reports, MNRE, Ministry of Power reports, International Energy Agency or US EIA reports, European Union reports, or IREDA's reports or IRENA report to understand and to know what exactly is renewable energy, energy efficiency, microgrid, renewable energy system, and what we call it as virtual power plant, right? Just, of course, you Google it, you'll try to learn more, but whenever you are defining in your research papers or project proposals, this is what we follow, what we majorly follow, the standardized definitions. So coming back to microgrid is nothing but a group of interconnected loads and generators supported by energy storage system, where the loads, few of the loads can be smart loads or controllable loads in such a way that you provide electricity delivery services to the end users. This is the definition given by the United States International Energy Agency, not United States, but International Energy Agency. Now, why this definition is important is one thing, the microgrid definition does not talk about renewable energy, which is interesting. That means if you have a diesel generator set and you are providing load to some 10 to 15 households of a village, and you have connected it through some series of cables, which are single phase, but distribution cables, and you are operating it in such a way that you can switch off one of the load, you can switch off one of the energy storage, you can do some peer-to-peer mechanism, then yours is a microgrid. That's what I'm trying to tell you. That's what I have not given microgrid here. Microgrid, as per definition, does not talk necessarily about renewable energy usage, right? But through the internationally, through intended national contributions, nationally determined contributions, which are INDs, coming from Confederation of Parties, COP, Paris meets, and the climate change meets, majorly it is said that whenever you talk about microgrid, you are making more than 80% of your generation needs through renewable energy systems. Okay. Now let us talk about energy affordability. Energy affordability means here it is the third point. I'm not changing the slide. I am still on slide number 3. Don't worry. So when we talk about energy affordability, this is something which is very new and very important. Whenever we talk about sustainable energy, we tend to, neglect costing effect, but we should not do that. If you are, see, just let us have one situation where you have all our green energy sources. The loads are also excellent loads. Your building is a smart building. It is preheating or pre-cooling your building space. It is heating and cooling whenever there is a low demand, and it is not heating cooling whenever there is a peak demand. But the whole system is costing you more than 20 to 25 rupees per unit. सोचो बिजली का बिल कितना आएगा. There will be a large, huge electricity bill. Electricity, especially in country like India, is a concurrent subject. That means that the state and the central government both have their jurisdiction. And it is also, we cannot shy away from the fact that it is also politically driven. So energy affordability is also very much important to all the classes of the society. So the societal needs also comes under sustainable energy management. So if you are writing a paper or you are developing a research proposal, there should be a dedicated section developing on the economic analysis. May not be the financial analysis, because that would depend upon how much loan you are getting, where you are investing your capital, are you going through equity or not. But that is some completely financial analysis. But economic analysis should be there. What is your system design? How much loss of load you can happen? And what is your net present cost? And what is your levelized cost of energy? And when will be your payback period? How will you be reducing those payback periods? All these things should be forecasted and there in the energy affordability. I hope now we have understood what a sustainable energy management is. Now, when we have understood what a sustainable energy management is, how different it is from a traditional energy management. Traditional energy management means something which we have been doing since last large number of years. Okay. Primarily, we focus on controlling the costs and optimizing the energy use. But when we talk about sustainable energy management, we also consider one thing which is very much responsible, that is environmental responsibility, right? Sustainable energy management takes a broader and a longer term perspective. It incorporates environmental considerations, majorly including the usage of renewable energy, reducing carbon emissions, alongside with cost efficiency. We don't lose the cost, but we also consider the cost efficiency into consideration. That means you are not only working on socio-techno-economic analysis, but you are working on socio-techno-environ-economic analysis. Okay, all of these things considered together comes under the umbrella of sustainable energy management. Now let us look into what are the key components of the sustainable energy management. If we talk about sustainable energy management, because the topic is sustainable energy management, but right now there are beautiful papers coming in IEEE transactions on sustainable energy, on robust sustainable energy management. Don't worry, this is not a catchy term for publication. Robust sustainable energy management is a thing of need. I'll tell you what robustness means. What happened? I told you about last 30 years, right? 3 decades, 4 decades, all of this is working. Renewable energy systems, renewable energy based microgrids, sustainable industrial practices have been there since last 2 decades. But what has happened is there are certain known and unknown disturbances that have happened in the system. I hope audience who have the background of electrical engineering are trying to understand this. Disturbances is something that we study in power system operation control or in power system dynamics and stability. Disturbances are those mathematical signals which are there inside the system or which may be provided externally, which are needed, which are not needed, but the system's control strategy should work in order to make the system resilient enough. There are 2 things that is very much important when we talk about power systems or energy systems majorly, because of course energy systems here majorly there is an assumption. I hope all of you understand is that through the course of the presentation I will be talking about electrical energy systems and not majorly about thermal energy systems. We'll be touching thermal energy system, but majorly as a power systems or electrical systems. Coming back to the point that I was raising is robustness. What is robustness? Robustness means ability of your system to make same or not make same, but to make sophisticated control decisions in presence of uncertainties and disturbances. That means there are certain inputs in your system which are uncertain, which are probabilistic, which are stochastic. Then also you may develop a PI controller, you may develop a sliding mode surface controller, you may develop a model predictive controller, or you may develop an ADRC, active disturbance rejection control developer. But all these controllers should have the capability of maybe changing their tuning values depending upon some disturbances which are happening in the system. That means robustness or a robust system or a robust controller is not something that you go to the market and get a different thing. Your existing PI controller can be robust. your already existing system can be robust. The only thing is you have to inhibit or include certain strategies which will take care of certain uncertainties or stochastic disturbance. I'll give you an example just to shy away, because this is just a first lecture only for making you understand and shy away from a little bit from electrical engineering. Just think of it that you are riding a bike, okay, and you see that there is a what you call it as some speed breaker in front of you. Robustness or robust automobile or robust bike means that the driver is different. You may be applying the brake some 100 or some 10 meters to 15 minutes before, so that you are going properly. I may be applying the brake just 1 meter before, and both of us, initial speed of both of us is 50 kilometers per hour. Robust automobile means even if I am applying the brake just 1 minute before, I may experience a larger jump while going through that speed breaker, but my bike should be stable enough after experiencing that larger jump. The shockers should be good, the wheelbase should be good, my handling should be good, and there should be safety of the passenger, the rider, and the bike. That is robustness. There may be certain disturbances happening in the system, not faults, but certain disturbances. Means somebody forecasted, made some machine learning algorithms, beautiful algorithms, and they said, okay, in 22nd September in 2040, evening 6 o'clock, the load will be this. But the load is just 30% of what was forecasted. The system should be robust enough to handle this. Right? Because that was not certain, that it happened uncertainly. Right? So for a robust sustainable energy management, it is necessary that you don't only talk about renewable energy integration and energy efficiency, but you also talk about data analytics, regulatory compliance, and also behavioral change. Regulatory compliance means if you are working on developing some blockchain-based peer-to-peer energy sharing and trading in that microgrid, the microgrid data that you will take, or if you don't have the data, the microgrid case study you have to take has to be complying with the regulation. In India, the regulation is IEGC, Indian Electricity Grid Code, that talk about voltage, that talks about distribution energy resources integration. All of this you can get it from CEA website, Central Electricity Authority website, and the same thing also talks about grid frequency regulation. Now, another thing that we are trying to achieve is net zero Viksit Bharat by 2047, renewable energy capacity addition by 2030. These are certain targets that our country has. We have to achieve those targets sustainably through sustainable energy management. So when we talk about, as I told you, next generation technologies, the next generation technologies considers all these things, right? First, we must handle the intermittency of renewable energy sources. We need to do good forecasting, day ahead, time ahead scheduling, integrate storage with our renewable energy systems so that the lights don't go out even when the sun is setting. Second thing is that we need to do energy management through decoupling from the consumption. That means the plug play situation should be there. We should be delivering our lighting loads, cooling demands, industrial demands with efficient technologies and smart controls rather than simply consuming more and more power. Third thing is very critical and very crucial. Why? Because in the coming years, we are moving towards digitalization. That means there will be growth in the electrical needs, in the power needs. Second thing is, if you will see, cities like Chennai, cities, Kanjipuram, they are expanding, right? So we are not only growing surface wise, we are seeing expansion in the greater parts of the metro cities where skyscrapers like, high-rise buildings are coming up. That means so for example, you have a 20-floor building, you will have the same solar PV rooftop potential. If you have a 10-floor building, you may have a same potential. Of course, someone would say sir, building integrated photovoltaic, but I'm saying in the coming 5 years, the rooftop solar PV will still be predominant as compared to the building integrated photovoltaic. That means it is necessary that grid stability is critical. We have fewer conventional generators which are providing inertia, we are trying to reach 100% renewable energy grid scenario. That means the inertia will be less. Inertia is nothing but when we talk about renewable energy systems, the rotational inertia is very less because majorly we focus on solar PV, wind, biomass based systems. Solar PV does not have a rotational inertia. We get virtual inertia from the converters. Wind energy power plants majorly focusing on doubly fed or induction generators, and biomass based power plants are a little bit of seldom used, but they also may be operated by through permanent magnet synchronous generators or DFIGs. So it is necessary that we include demand response and advanced operation. These are the things that are majorly my research scholars are working upon. One of my research team is working on peer-to-peer energy storage, peer-to-peer energy systems. And one of my research scholar team is working on the dynamic demand response based virtual inertia control. So in short, what I'm trying to say is generation, yes, is creating, if I may say, green electrons, but the management is very much important because the management is transforming this existing system into sustainable and also reliable energy services. Now let us look where we are right now. And as I told you, why it is important to integrate buildings as a sector in sustainable energy management. I encourage all of you to also go through, if I can also chat, I'll include this through this report, State Energy Efficiency Index 2024 report. It is an open source report. You will get this report, which has been developed by Bureau of Energy Efficiency and Alliance for Energy Efficient Economy, AEEE India. If you go through this, there are certain sectors that they have, the government of India through BEE has recognized as energy intensive sectors. That means if you work on these sectors, make them smart, then we are parallelly working on smarter systems, smart cities, smart villages systems, and also working towards energy efficiency, right? So coming back here, our real estate, as I told you, construction sector is massively growing. We are nearly $477 billion industry contributing to 7.3% of the economy. We are achieving or trying to achieve a $7 trillion economy by 2030. We have a net zero target set for 2070. So buildings are going to play a major defining role in this transition. Currently, if you talk as buildings as a sector, currently buildings account for about 1/3 or 30% of our country's total energy demand, and they contribute to more than 1/4 of the greenhouse gas emissions. So we are not only efficiently or conserving the energy usage, but we are also working towards the environment sustainability. Why I am saying all of this is because in the previous slide we have seen that whenever we talk about sustainable energy management, we have to talk about the environment also. That's why this point was raised. And of course, remember that most of the buildings that will exist in 2050 are yet to be built. So in the next 10 years, they are yet to be built. So it's not only building energy efficiency, and we cannot just go through demolishing our old buildings where we have metro cities or Mahanagars coming up. So the choices today will lock in the emission targets for decades. Now, if we talk from the power grid operation side or the power grid operator, the challenges are growing. You are saying, okay, a good energy efficient building, good looking building, net zero energy building. But there is a dynamic demand that is coming from renewables. There are new loads like electric vehicles, cyber security risks, and greater pressure on grid balancing. So the message is very clear here that if our country, our Bharat, our India wants a sustainable energy future, buildings cannot be only remaining as passive consumers. They must evolve into a grid responsible, flexible assets supporting our country's renewable integration, frequency regulation, and ultimately enabling Bharat's net zero energy dream. Second thing is, there is a large number of attention which is going towards renewable energy system, as I told you. But the grid operators, the story behind the grid operators is also very much important. We have already seen this during pandemic. Our honorable Prime Minister came up with that 7 baje thali bajana and switching off the lights. You know, there was a dV by dt, di by dt, we all understand. For a smaller period of time, there was a huge transition of voltage. It was the grid operators, it was the energy storage technologies, it was the large hydropower plants of northern and northeastern India that supported our grid. We are now one nation, one grid, one frequency. So that is why it is very much important that we understand from the perspective of the grid operators as well. Why we are choosing building, as I told you, that we are not only increasing surface wise, but we are increasing vectorial as well. Where there are high-rise buildings coming up, you may install a small wind. If you have a 20-floor building or a 5-floor building and you have a good wind profile, you may have a small integrated renewable energy systems as well. Now, when we look into inside the buildings and bifurcating them as residential or commercial buildings, it is necessary that we understand what are the major services or major devices which call upon the energy intensive equipment. If we talk about residential, large number of loads are fans, air conditioners, and lights, refrigeration. And when you talk about commercial buildings, there is a large number of HVAC loads. HVAC stands for heating, ventilation, and air conditioning systems. Heating, ventilation, and air conditioning systems. And lighting systems. That means two things. First is the air condition. Of course, either you're conditioning that air through fans or air conditioners, and lighting. These two are the major energy intensive sectors inside the buildings. One another important thing is, it's not only about energy. What COVID has done, post-COVID, a large number of work from home scenario has come up. Residential building loads has increased. The grid operator was not ready for this. Residential loads has increased. Air conditioners, we used to have only one air conditioner in the bedroom. Now they are installing air conditioners in the living room, in the study room, because they have to do work from home, right? Second thing, if we talk about commercial sector or institutional sector also, the mass flow rate, one thing is the air is coming from the AC, which is a cool air. Second thing is how fast that air is coming, which is the mass flow rate. The mass flow rate standards are also changing from ASHRAE because post-COVID, it has seen that the time taken for the amount of fresh air to come inside a building space, and depending upon how many occupants are there in the building space, the amount of exhaust air has to be conditioned as well. So not only 5-star, 4-star energy efficient ACs, but 5-star, 4-star environmental emission based ACs are also being coming up. So this means again, inverter air conditioners are coming up majorly. I don't know if all of us are seeing right now in market, in e-commerce, inverter ACs, 50% inverter AC, 75% inverter AC, 100% inverter ACs are coming up. What are these inverter ACs? Inverter ACs or fixed speed ACs have a converter. Inverter ACs have a converter before a compressor or a condenser. Fixed speed AC does not have that inverter. It has just a small transformer. Through inverter, the input supply to the compressor can be changed for a few seconds. That means for a few seconds, the supply frequency can be changed. So if I can tap it for hundreds, thousands, and 10,000s and millions of air conditioners, I can provide grid support. One thing again I want to tell you, those who have already worked on demand side management, they will understand this. But those who are trying to understand and trying to enter into demand side management or demand response, whenever you work on grid regulation services or ancillary grid services using demands, you have to work towards aggregation of large amount of loads. One particular load, one single load cannot provide regulation of the capacity of the grid. neither power regulation, which is real or reactive, neither control of voltage or frequency. You need to aggregate a large number of loads. This is where smart grid comes up. This is where a distributed system operator comes up. In India, we have power grid operator, and the distribution system operator is the operator who is providing us the electricity bill. So we are not in a smart grid scenario. In a smart grid scenario, we'll see the definition from the Ministry of Power through National Smart Grid Mission. That means where the grid operator should be there, a distribution system operator should be there, who is able to control the operation or working or of our certain loads. May not be full loads, but certain loads. Such certain loads are called as flexible demand resources. Flexible demand means, for example, light. Traditionally, how lights we have, either we switch it on, तो light जल जाता है boss, or we switch it off, light बुझ जाता है. If there can be certain luminaries, certain lights in such a way where we are switching on, switching off, but we are using our mobile to change its illumination capacity. I'll give you an example. I encourage all of you to open your mobiles, go through the upper page, you will have torch. If you will double click on the torch or keep on pressing the torch, there will be a bar which will be opened in your mobile. You can change the illumination level of the torch. Of course, if you are keeping it at full bright, the battery of your mobile phone is using at a maximum level. If you are keeping it at minimum bright, the battery usage is at a lower level. Flexible demand resources. All over the world, large number of thermostatically controlled loads are coming up. Smart ACs, smart refrigerators, smart water heaters, smart space heaters, all over the world. Because there is, in India, we have majorly cooling load, but northeastern states and in all other parts of western states, Western European countries, we have heating loads. That means the thermostat, the remote control, can it be controlled by my distribution system operator or my utility provider? That is what we will be trying to see. So this is just a few example or a basic thing of what a thermostatically controlled load is. In India, there is a huge increase of sales of air conditioners. 3-star, 4-star, 5-star fixed speed, 3-star, 4-star, 5-star partial inverter ACs, 3-star, 4-star, 5-star energy rated full inverter ACs. Huge market, and it is booming and booming like anything. Before getting into buildings to grid integration, it is necessary for all of us to first understand what is building energy systems, smart grids, and how do we integrate them. Building energy systems are nothing but the systems which can be a physical process which is occurring inside a building and with the building and the environment, and it can also be an equipment or a machinery, right? So majorly, there can be HVAC systems, electrical motors, some smart plugs, smart loads, and some auxiliary systems, energy storage devices, building integrated photovoltaics, rooftop solar PV systems, rooftop small wind systems. All of these systems which are providing demand services to that particular building will be building energy systems. Okay. Now let us move to what is smart grid. As I told you, I will be giving you a definition coming from agencies. Smart grid in India is defined in the website of National Smart Grid Mission and also in its white paper report, which is again headed by the Ministry of Power. Smart grid, they define the NSGM, the National Smart Grid Mission defines smart grid as an electrical power grid which has the capability of automation, communication, and information technology systems in order to monitor and control real power and reactive power in real time or near real time in order to match the generation and demand up till the end use consumption level. Again, I repeat, up till the end use consumption level. Abhi kya ho raha hai? What we are trying, what is happening right now? We have a meter From the meter, we are getting electricity to our homes. The jurisdiction of, and then we are getting bi-monthly or monthly electricity bills. The utility provider through which in Delhi we get bill from BRPL, DACS Rajdhani Private Limited. BRPL does not know what is happening behind the meter, BTM, behind the meter, it is not known to them. Utility does not know it. How many ACs I am using, where ACs I am using, what is my pattern of usage, they don't know. They just know the cumulative demand, right? So we are not in a smart grid scenario. Smart grid means that there should be some boxes, maybe some modems, some optical fiber, we don't know, but there should be some system where the utility may be able to monitor my appliance, not all the appliances again, but few appliances like air conditioners, refrigerators, water heaters, and may be able to control them. Then only we will be able to achieve the smart grid scenario. I told you that I will be giving you complete terminology and bifurcation about net zero energy building also. So we understood what a building energy system means. Any system which is consuming energy, it can be a process also, is a building energy system. Point number one. Point number two, what is a smart grid? Smart grid can be any grid that has IT and ICT technologies where you can monitor and control the power flow up till the end user. Third, net zero energy building. Net zero energy building means it is already an energy efficient building. It is very much important for us to understand. And a building which is not energy efficient can never be net zero energy building. What I'm trying to say is net zero energy means one thing that comes to our mind is mathematics. That on an annual basis, the total of energy used by the building should match the total number of energy generated by the building. But if that energy is being generated through gas turbine power plant or diesel generator, then we are not a net zero energy building. Hence, this is very much important that a net zero energy building or a net zero energy campus or a net zero energy society community will be an energy efficient building where on a source energy basis, the actual annual delivered energy is less than or equal to the on-site renewable exported energy. Very interesting definition. Why? In the definition of microgrids, there is no concept of renewable energy. Just loosely, they want to encourage renewable energy usage. But when we talk about net zero energy building, it means the energy usage and energy generation on an annual calculation should match, but that annual calculation should come from renewable energy resources, right? So we understood what smart grid is, what building energy system is, what net zero energy building is. Let us now understand what a green building is. Again, in India, we don't have a single definition, but majorly what I have seen through governmental reports is we adopt definition from these three agencies. The United States Green Building Council defines green building as a holistic concept that starts with understanding that the built environment can have profound, both negative and positive effects on the natural environment, and not only on the natural environment, but also the occupants. The World Green Building Council provides a much better and a cleaner definition where they say that, okay, a building is a green building according to us if in its design, construction or operation process, construction process and operation process, they are reducing or eliminating any negative environmental impacts and trying to create positive impacts. In this definition, they talk about building occupants. In this definition, they don't. They only talk about the environment, right? One important differentiation. The United States EPA, Environmental Protection Agency, defines green building and they provide a much broader definition. They say the green building is the practice. This was a concept, this was an infrastructure, this is a practice of creating structures and using processes that are environmentally responsible and resource efficient throughout a building's life cycle. What is that life cycle? Site here, the life cycle is only design, construction, and operation. But here, the life cycle is siting, designing, construction, operation, maintenance, renovation, reconstruction, or a deconstruction. In all these activities, there should be a complete life cycle that you are providing some positive impact on the natural environment. So if you'll see, this is nothing new. This we are doing since our tradition. Optimal usage of earthly resources. Optimal usage of Jal, Vayu, Prithvi, Akash. Jal, Pani, water. Water usage, water conservation. Second, Vayu, using of natural air as much as possible for necessary ventilation. Prithvi, earth, making use of the soil in an efficient way, not throwing away the nutrients. Last, Akash, sky, making use of sky in such a way that whenever we require light, we are getting the radiation in such a way that we are depending on the artificial light as much minimum or as low as possible. Again, optimal usage of Jal, Vayu, Prithvi, Akash. That means in energy efficient buildings or net zero energy building, we only talk about energy. Two major things: electrical energy, thermal energy. Again, electrical energy, thermal energy. Heating needs, electricity needs. Heating or cooling needs, electricity needs. But in green building definition, we also focus upon waste and also water usage. From now onwards, whatever I'm trying to put forth will not be a concept of green building, but under the jurisdiction of net zero or energy efficient building. Now let us try to understand more about the buildings to grid integration. See, traditionally buildings have been passive consumers. Once unidirectional flow of power from the grid through the meter to our homes. With the advent of on-site small renewable energy technologies, small mobile renewable energy sources, energy storage technologies, electric vehicle charging stations, buildings have had a huge potential of acting as active devices, active equipment. The grid operator can see a building as a peak power plant, can see a building as a active energy storage system, can see a building as a virtual energy storage system. Virtual, VESS. It can make use of the thermal inertia and electrical inertia inside the flexible demand building resources so that the grid operator gets few milliseconds to seconds frequency control and voltage control from the distribution system side. So let us dwell more and get more technical inside the concept of grid interactive building energy system. Grid interactive building energy is a building which is already an energy efficient building, which uses some smart next generation technologies, maybe blockchain, maybe active disturbance rejection control, maybe model predictive control, maybe robust PI control, in order to make use of the distribution energy resources, in order to optimize the energy usage, not only for the occupants, but also for the grid operators. And all of this should be happening in an optimal way. That means in a cost optimal way. I will provide you with some framework which I have developed in my research and published the papers, but I really want to tell you this disclaimer that this is not a universal thing. You may use or you may develop your own integration framework, right? Because this is a novel concept. So if we talk about buildings to grid integration framework, the stepwise procedure or a hierarchical procedure that I have used or adopted in my study is that I have started with modeling and simulation. We make use of building energy models. There are three types of building energy system models. One is called as white box model, one is called as black box model, and one is called as gray box model. White box model means that for a system, you develop the system using theoretical textbook equations. You make use of the fundamental principles of the building energy physics. You develop Newton's law of conduction, convection, radiation equations. You develop Ohm's law equations. You develop nodal analysis, Kirchhoff's equations, and then you develop the models. You give certain inputs and then you get the output. Such systems are called as white box systems or white box models. White box models are the most accurate models, but as you must have pointed out or realized by now, they are very complex and they require huge computational demand. And I told you that this is a very major issue because flexible loads providing grid support have to be aggregated in thousands, 10,000s, and millions. Right? So computational burden of one building model will be very much more. Second are black box models. Black box models are those models where you just give the input, you don't know anything about the model, so it is completely black. You get the output, you do pure experimental results, and then you do input-output regression or machine learning analysis. Such models are heavily dependent upon data. They are very simplistic models, but they are heavily dependent upon the data. The data integration, the data analysis, if there is an error, there is a tendency that the building model will be of huge error, right? And they are least accurate models. Gray box models are combination of white box models and black box model. That means you do use equations, and develop the model structure, but the values of the parameters which you have used in the model structure come from data, come from parameter estimation techniques. I'll give you an example. Just think of an equivalent circuit of a transformer. So you know there is a primary resistance reactance, secondary resistance reactance, but what are those values? So you do open circuit and short circuit test to get those parameter values. That's a concept of gray box. After you develop the models, you develop the model for a building, you develop the model for air conditioner, you develop the model for a lighting system, you may develop the model for an energy efficient motor, depending upon the functionality of the building. Then one thing is very much important, that you develop a multi-objective optimization problem. The problem that I have developed is for a comfort, maximization of comfort, minimization of energy optimization. And I'll tell you why this is necessary. I'll give you an anecdote. As Professor Lakshmi ma'am pointed out during my brief introduction, that I have done postdoc which was sponsored by Netherlands government, and it was headed by Eindhoven University of Technology, Netherlands. So in 2020, we had a successful project closure meeting. In that project closure meeting, it was happening in January. It was happening in Netherlands. It was happening in TUE campus. We went there from India. Beautiful campus, very energy efficient campus. One of the project leads, she's a faculty. She's an energy enthusiast. So she does not use any motorbike. She uses cycle. Okay, a bicycle to commute. The meeting was in the 5th floor. The building is the most energy efficient building. So the air conditioners and the elevators are operating automatically, but it will operate at an optimal occupancy. That means if you are a single person, the lift will not come. The lift will not operate. The lift will operate at a 30% to 50% occupancy. Point number one. Second point, that is the elevator. The air conditioner in January, the outdoor temperature is -0 or 10 degrees Celsius. And the air conditioner or the heating system will operate accordingly. So coming back to my project investigator, she was coming and she was getting late in the meeting. So she came in the bicycle, parked the bicycle. Then the meeting was in the 4th floor. So elevator was not coming because there were not many people. So she climbed up the stairs, went inside her room, tried to switch on the AC, but AC was not switching on because heating mode was coming. Do you think that this is smart? भाई energy efficient है, ICT technologies है, but do you think this is smart? It is necessary that we take into consideration the occupants' preferences. You cannot have a universal control strategy because your control strategy may work for your classroom or your what you call it as staff room, but that same control strategy may not work in the in the library or in the gym. because the occupancy, the pattern, the work of the occupancy is different there. The nature of activity is different there. So it is necessary that we understand the comfort and energy optimization problem. Then you develop a grid interaction modeling. How do you model the grid dynamics and integrate it inside these equations, these models and comfort equations? Then you go for implementation and evaluation. I am still writing project proposals. I still have to go through hardware implementation, but we are working on small test systems. And then after this, you work on fault detection and diagnosis of the FDT systems. Before we start building energy models, it is necessary that we understand what are the parameters that should be considered. So these are the parameters that I have taken in my study. Detailed explanation, you can get it from my RACR paper. The parameters that have been considered are some input parameters, output parameters, and some are system parameters. These are majorly system parameters. And the nature can be controllable or uncontrollable. Uncontrollable means that my control strategy, my PI controller will not be able to change the dynamics. How it is changing with respect to time, that graph cannot be changed. And certain are controllable parameters. Achha. One thing that I really want to put forth here is, I encourage the participants to kindly go through this slide. There is one small limitation of my slide here. There is one, I will not say mistake, but small limitation. There is one parameter which I have taken as uncontrollable, but can be controllable. Should be regarded as controllable, not can be, should be controllable. There is one, let me say, there is one mistake in this slide here. Can anybody care to point that out? There is one mistake here. Anyone? One parameter, there is some parameter that I have taken as uncontrollable, but is actually controllable. Anybody? Room air temperature? Yes, ma'am. Your air temperature I have taken controllable only, ma'am. My question is, for example, solar radiation, I have taken uncontrollable. Solar air temperature, outside air temperature, uncontrollable. Thermophysical properties, uncontrollable. Wind, uncontrollable. But the control strategy can consider it controllable. Building location, very good. Building location, why I have taken uncontrollable, ma'am? Because the first thing, whenever you develop a model, the first thing that you give is latitude, longitude, and wind characteristics. This is very much important, ma'am. So this is something which will remain fixed throughout my control strategy development. So this will be uncontrollable. That means my controller cannot change latitude, longitude. You're getting my point, ma'am? So building location will be uncontrollable, ma'am. Okay. Someone has said building construction elements. Interesting. Thermophysical properties are properties such as which are thermal and physical. That means thickness. I'll give you an example. If you are sitting inside your home, in your room, you can see geometrically you are sitting inside a cuboid. You have 4 walls around you. You have one roof and you have one floor. So one roof, floor, and everything. You will have a brick wall. Then you will have some paint. Then you will have some insulation, some putty, and you may have some wallpaper. Each and every this is a layer which will have a property of thickness in millimeter, specific heat capacity, density of the material, and thermal conductivity. These are thermophysical properties. As I have said for building location, while developing a control strategy, before I have to develop a model. So I'll develop a model that I am developing a model for a building in Chennai, and that Chennai building has these properties. So these properties are already fixed. My controller will already regard these properties as fixed. So these are fixed input properties. Okay, without wasting time, thank you so much, all the honorable, August audience which has interacted. One thing is solar radiation, and I'll tell you why. Why my controller? If I develop a controller, let us say smart home controller. I have developed a controller, my control strategy of building to grid integration. where the sole radiation I have taken as uncontrollable is wrong, but should be controllable. I'll tell you. All of us know windows and all of us know curtains. Now, with the advent of ICT technologies, Google Home, Alexa is able to control opening and closing of the blinds or opening and closing of the curtains. That means some part of solar radiation through window can be controlled by my controller, how much of it is coming inside the building space. Of course, that is the wrong mistake that I have taken. Of course, one of my scholars is rightly working on here because this makes a very dynamic optimization problem. It becomes a very complex problem, but a very interesting problem. So solar radiation should be controllable. It can be controlled inside the building by my control. That is what I wanted to put forth. So notwithstanding time, I told you about layers. So that wall putty, wallpaper, brick, cement layer, paint, each and everything is a layer. So you need to develop a multi-layered building energy model. The model that I have used is a thermal electrical RC network model, thermoelectrical analogy. What we do is we must have studied this in measurements and transducers, that each and every signal we calibrate towards electrical. In a very similar fashion, the processes are calibrated here. Heat flows from a higher temperature region to a lower temperature region. Electric current flows from a higher potential point to a lower potential point. So the heat flow becomes electrical current in amperes and temperature becomes voltage points. So think of it as a single wall, a multi-layer wall, where I am modeling that wall. Equivalent circuit of that wall is a 3 resistance 2 capacitance bridge. Now I told you that I have used gray box modeling. So I should know what is the value of R1, R2, R3, C1, C2. If you go through architectural diagrams or blueprints, the architect will give you total thermal resistance and total thermal capacitance as the ratings of that particular multi-layered building energy model. RTH and CTH will be given to us. R1 will be some fraction of RTH, R2 will be some fraction of RTH, R3 will be some fraction of RTH in such a way that R1 plus R2 plus R3 will be RTH. That means X1 plus X2 plus X3 should be 1. In a very similar fashion, Y1 plus Y2 should be 1. As I told you, we did not have the funds, so I have worked on white box modeling first. So I used finite difference equations to develop a building energy model, which is a complete white box model, the most accurate model in MATLAB. So I used lines of code. Then I gave that model some input and I got the output. Then I developed this 3 resistance 2 capacitance model. R1, R2, R3, I used a guess value. C1, C2, I used a guess value. I gave the same input which I gave to the benchmark most accurate model. I gave the same input to my error model. The output was erroneous. So I compared the sum squared error of this output and this output and developed into a optimization problem. If you are interested, I request you to go through my applied energy paper. You have all the detailed equations and the flowchart and the working and the operation is there. This I did for one wall. And I told you that we are geometrically sitting inside 6 walls and 2 windows. So I have developed this model. So each and every block which you are seeing here, AW1, AW2 is actually a 3 resistance 2 capacitance network. So there is a 3 resistance 2 capacitance network here, 3 resistance 2 capacitance network here, 3 resistance 2 capacitance network here. Now, when I have developed this geometry model, it is necessary now I develop the air conditioner model. I have used an all seasonal HVAC system, heating, ventilation, and air conditioning system. The data that I have taken to test this model is coming from Indira Paryavaran Bhavan model. I have used Energy Plus for this location, and these data is available through some 10 or 15 reports. And I have given that inside my model. I have used these test inputs for my model and developed this as a transfer function state space model. Second thing, and I have achieved some results. One thing that I really want to put forth here also, because this is also a next generation technology, is occupant comfort centric technology. we can use, I hope all of us know this, we can use mobile phones to switch on, switch off our smart AC, TV, smart refrigerator. Think of it in such a way, can there be an app where you are switching on, switching off, changing the temperature of your AC, and that app is controlled by the grid operator? Beautiful. That is buildings to grid integration. We are trying to develop the test setup in my faculty room, in my staff room. We have already achieved simulation-based results. We have published these simulation-based result in SCI indexed papers. We have achieved energy savings. Now you will say that energy savings are less, but let me tell you that it is a multi-objective optimization. I am not only achieving energy saving, but I am also achieving occupancy comfort facilitation. I am increasing the occupant's comfort as well. So for the last 1.5 hours, what we have majorly focused upon is what is the, just a second, I think there is a certain mistake here. 1 minute. So what we have achieved till now is, for a sustainable energy management, it is necessary that we, yes, integrate renewable energy, but not only just improve generation, but also manage that generation using the demand side resources. We should work towards socio-techno-economic environmental analysis and try to develop smart grid scenarios. What I'm trying to achieve is, for the next short-term research goal, is that I want to develop a software-based tool where we can evaluate the engineering, social, and economic aspects of the prosumer-based energy systems and then assess the energy and environmental impacts. These are certain research papers that you can go through. This is a brief about, if you are interested and try to work and are eagerly and are looking forward to work on this, I encourage you to go through our institute's website, our departmental website. There are excellent faculties, young faculties who are working in EVs, who are working in vehicle to grid, who are working in forecasting of renewable energy technologies, who are working in demand side resources. We have industrial level softwares in our laboratories. We are a new department, so we are getting a good amount of funding from the government, and we are trying to develop next generation laboratories. And if you are more encouraged, I encourage you, all of you, to go through our institutes and our departmental websites, where we are trying to work or build a sustainable future together. I sincerely thank all the August audience for such an interactive session. They were really putting forth in the chat box as well. Also to Professor Anisha ma'am, to Professor Lakshmi ma'am, and all the organizers of the Department of Electrical Engineering and the whole thank you, ma'am. Thank you for giving me the opportunity. Thank you, ma'am.
Participants, you can ask your queries now. Participants, you can ask your questions or otherwise raise your hand. You will be unmuted. Sir, I think there is no doubt from audience. Uh,
Okay.
On behalf of the organizing team of today's enlightening session on introduction to sustainable energy management using next generation technologies, I express our deepest gratitude to Dr. VSKV Arish for sharing his valuable knowledge, experience, and insights. Your lecture has shed light on how sustainable energy solutions, where when integrated with the next generation technologies, can transform the way we manage energy in the built environment, industries, and power systems. The clarity with which you explain complex concepts, the relevance of real world applications, and your emphasis on innovation and research have truly inspired all of us. I am certain that the ideas discussed today will encourage participants to explore new approaches and contribute meaningfully toward a greener and more sustainable future. We also thank you for patiently addressing the queries and engaging with the participants, making the session highly interactive and impactful. On behalf of the organizers and participants, I once again convey our heartfelt thanks to you, Dr. Harish, for sparing your valuable time and enriching this faculty development program with your expertise. We look forward to more such opportunities to learn from you in the near future. Thank you, sir. Dear participants, now we will have a photo session. Please switch on your video. In the meantime, the feedback link is posted at the end of each session, and now it is posted in the chat box, and it will remain open for 2 hours only. So participants are kindly requested to submit their feedback within the given time. Now, candidates, please switch on your video. Badran sir?
Yes, madam. Taking it.
Okay, sir.
Still few more to come on. Okay, shall I go ahead?
Okay, sir.
Perfect.
Shall
Yeah.
we start next session, sir?
Yes. So I have taken the photo. Yeah, thank you.